Okay, good evening, students. We are discussing today the practice paper 3. For the today's paper, I gave you a answer sheet to get your answers, and we are going to use that also during our discussion. So we can see what are the actual MCQs that felt difficult for the students, and we can do a productive discussion today. Okay, so this paper contains 8 MCQs, 5 from the atomic structure, and 3 MCQs are from the your chemical calculation lesson. Okay, and recently we completed stoichiometry topic in our last week classes. So today we are going to do 3 such chemical calculation questions in order to just revise that and to make it more understandable. As earlier paper classes, for this also you have to write a good review, and you must show that one in the theory class to me. Okay, so if you are on online students, you have to send the photos of the discussion once you have completed the writing. So let's go into today's paper. I'll share the Google form and I'm going to do the class from that. Okay, so this is your first question from atomic structure. Consider the following discoveries made regarding atomic structure. Okay, there are 2 discoveries given. Radioactive materials produce 3 types of emission: alpha, beta, and gamma. Okay, alpha, beta, and gamma. So the symbols given there should be corrected. Okay, so the alpha, beta, gamma symbols you have to correct and add there. Okay, and who discovered this alpha, beta, gamma radiation? Okay, so there may be questions in our A-level paper which is asking the names of scientists. Okay, so we have to remember what each scientist discovered, what each scientist invented, right? The theory related to their names. Okay, so there may be questions in this manner, right? So radioactive materials, alpha, beta, gamma radiation was discovered by Ernest Rutherford. Ernest Rutherford, right? And he's the one who named this alpha, beta, gamma radiation, right? But radioactivity was discovered by Henry Becquerel. Okay, you can see Henry Becquerel in our answers also. He discovered the radioactivity, okay, the phenomena. Okay, so phenomena that unstable nuclei releasing radiation, he discovered that uh, radioactivity, not the alpha, beta, gamma. Alpha, beta, gamma was discovered by Ernest Rutherford. So our answer should be either fourth one or fifth one, right? So we have to see what is the proper answer by examining the second point. Okay, second point is naming the fundamental unit carrying electricity as electron. So who named the electron? Who named the electron? Who gave the electron that name? Right? He's Stoney. Okay, John Stone G. Stoney is the scientist. Just remember it as Stoney. So our answer should be the fourth one. Okay, our answer should be the fourth one. We'll go and see how your answers were there for that question. Okay, so you go to the first MCQ. Here's the answer. So I got 22 responses. Out of that 22 responses, 16 of you have selected the correct answer. Only 5 of you have corrected the second answer. Why did you selected that one? So that you have a confusion between radioactivity and radioactive particles. Those are two things, Lama. Okay, so those who selected the answer 2 have a small confusion with Henry Becquerel and Ernest Rutherford. Okay, so again I'm telling, Henry Becquerel is the one who discovered radioactivity, and he didn't discover alpha, beta, gamma. Alpha, beta, gamma was discovered by Rutherford. So you must write a clear review for that one. Okay, students, I hope you understand what I'm telling. So now see, when we are having the answers, we can do a very productive discussion. I know exactly why you got there wrong. So for the first MCQ, here's what you need to write. Okay, so let's write Henry Becquerel. Henry Becquerel. Okay, Henry Becquerel. Henry Becquerel, what did he do? Henry Becquerel discovered radioactivity. Discovered radioactivity. And our Ernest Rutherford is the one who discovered alpha, beta and gamma radiation. So in your paper, you have to correct this alpha, beta, gamma symbols. He is the one who discovered alpha, beta. Understood? So don't get this confusion. So 5 of you got, unfortunately, the wrong answer because of that small confusion. Okay. So 3 radioactive particles discovered, the three types of radiation, let's say 3 types of radiation. Okay, so these are 2 different things. So radioactivity discovery is a very interesting thing. Just search on how he discovered radioactivity. It is not asking for the A levels, but it is interesting to know. Okay, and radioactivity, you have to know what is the definition of radioactivity. Radioactivity is, okay, losing of energy and matter. This is some rough definition. Okay, energy and matter by unstable nuclei for the sake of stability, or you can say to become stable. In your book also you have a proper definition. Just know it. It is not again asking you to write in the level exam, but it's good to know. Okay, losing of energy and matter by unstable nuclei to become stable. Very simple definition. Okay, so I said energy and matter. So Rutherford is the one who discovered what are those types of energy and matter. Okay, so 3 types of radiation: alpha, beta, and gamma. So what are actually alpha particles? Last day we learned that in the theory class. Alpha particles are helium nuclei. So we write them as this helium-24. So it's having +2 charge and relative atomic mass of 4. And beta particles, we are writing them as -10, okay, because it is having a negatively charged particle with a negligible mass. Even though we write 0 here, remember Lama, it is having a negligible mass. Okay, and beta particles are having equivalent to electrons, and gamma particles are, those are electromagnetic radiations. In your spectrum of electromagnetic radiation, you know, where the gamma particles are coming, it is having the highest energy. Okay, highest frequency, lowest wavelength. In your electromagnetic radiation, gamma is the last one. Okay, so let's repeat. Electromagnetic radiation, electromagnetic spectrum, it is starting from what? Radio waves, then you have microwaves, infrared waves, visible, then you have gamma, UV, then you have X-rays and gamma rays. Those are the electromagnetic spectrum. Okay, in there you have the gamma at the end. So gamma is having the highest energy. Okay, so like that you can remember. Ernest Rutherford. So that was the reason. Then the name of electron given by Stoney. So you can write that as another point. Electricity was discovered, Lamai, a long time before than the discovery of cathode rays. Okay, so when they discovered electricity, scientists thought that some particle may be responsible for the electricity, some particle. So Stoney called that particle as electron, but he couldn't discover that one. But he just named the particle. He gave a name. So electricity carrying particle is electron. That's how the name came. Okay. Right. So you can write that too. Stoney name the electron. So electricity carrying particle. We call it as electron. That's what you need to know here. Okay, so that is the review for the first MCQ. It's not that difficult. You all can understand. Okay. So let's go back to our paper. So do you have any doubt here, Lamai? Anything to clarify? Right. Now let's look at the second MCQ. Here's the statements given. It is asking for the incorrect statement. Okay, so 5 statements are regarding the experiments and general things that we discussed regarding the atomic structure. So let's first of all go and see what are your answers for the second one. Second one. Okay, for the second question, most of you have selected the correct option. So out of the 24 students answered, 18 got the correct answer. Okay, only 3 students got the answer as the third one. Okay, I'll explain about that one. So I think most of you are okay with the question. So now we'll think about how to write a good review for this one. Huh? So look at the first statement. It is telling the rotation of light paddle wheel kept in the path of cathode rays confirms that cathode rays are particles. Okay, so this statement is true. So how do you explain that this statement is true? Yeah, you're asking a doubt regarding earlier question. Eugene Goldstein. Eugene Goldstein is related to what? Eugene Goldstein is related to positive ray experiments, anode ray experiments. Okay, he's the one who did anode ray experiments. And there are some other scientists, Robert Millikan. He discovered the charge of electron, Robert Millikan. And Ernest Marsden is involved with the what do you call this, gold foil experiment. Ernest Marsden is involved with the gold foil experiment, and Niels Bohr presented the Bohr model. Okay, so that those are the other scientists, right? So again, Goldstein did positive ray experiments. Understood that? Right. Now let's write about that statement, rotation of paddle wheel. So in the second MCQ, the first statement you can tell if the paddle wheel is rotating, that means Lama, it is having a kinetic energy. So kinetic energy formula is half mv square. Okay, so that kinetic energy is given to the paddle wheel by electrons. That means electrons are also having kinetic energy, right? So that means if they both have, if the electrons are having kinetic energy, they must be particles. Okay, so you can say if electrons have kinetic energy, those must be particles. Those must be particles. Okay, this one can be explained by momentum also. Momentum formula is P equal mv. Okay, so if paddle wheels are rotating, that means they have momentum. That momentum is given by electrons. That means electrons are having a mass also, right? That is the explanation for the first one, and it is correct. Then you can go to the second statement. Second statement, we'll write a short review why those statements are correct. Okay, because they're asking for the incorrect one. Second one, when alpha rays radiated towards a thin gold foil, majority of the particles pass through the foil with no deflection. So in gold foil experiment, we have three observations. Okay, we can draw a small diagram. So this is how alpha rays are coming, and this is our gold foil. This is our gold foil, and majority of the particles are going without any deflection. Okay, without any deflection. So if you send 10,000 here, these are just numbers just to explain. 9,990 is passing through without any deflection. You need to write the reason here why this is happening. Why this is happening? The reason is most of the space of atom is empty. That's why majority of the particles are passing through without any deflection. Okay, and some particles are deflecting in small angles because they pass through the pass near the small positive nucleus. You need to write the reason there. And some of them are bouncing back because why? Because they directly collided with the nucleus. Okay, so because of the nucleus, these particles are bending and these particles are bouncing back. Okay, so in your theory book you can refer, we not wrote these things, and this is the position A, these are the B and C position. Okay, so to your review Lamai, please add those statements also, why these are happening. Understood? So the explanation for the second statement is coming from what? The name of this one, gold foil experiment. Okay, gold foil experiment. It is given in the statement also. Is that clear to you all? Now some of you selected this third statement also. Okay, some of you have selected the third statement also. So third one is like this. See that one. James Chadwick discovered the neutron by radiating alpha particles at a target of beryllium. Okay, that one is true. We will be discussing this in next classes. James Chadwick is the one who discovered the neutron. That part is correct. And he discovered that by doing this alpha particle experiment. Okay, he targeted beryllium or boron sheets to this experiment. So I will be explaining that one in our classes. So I'm not going to talk much about the Chadwick experiment, but just write Chadwick used beryllium, the chemical symbol is Be, and boron, B sheets. Okay, so that you need to know beryllium and boron sheets. And he fired alpha radiation, fired alpha particles. Okay, so that one is also true. Okay, some of you have selected that one. So I think that because of the name Chadwick haven't come up yet in our discussion. Right, and another question, how the emptiness contributed to the passing of alpha rays. If the matter, most of the space of the atom is empty, alpha rays can easily pass through that one. Let's take the model and see. Okay, so all these space is empty according to Rutherford planetary model. Okay, so alpha rays can easily pass through any of these places. Okay, so they are passing without any problem. But once they pass closer to the nucleus, they repel. Right? Once they come directly towards the nucleus, they will bounce back. That's what happened. All other alpha rays will easily pass through. I hope that is clear to you now. Okay, so like that, ask any problem, it's fine. Yeah, because some of them are deflecting toward the direction of B because they pass closer to the nucleus. Okay, because the nucleus is positive, no, Lamai. Alpha particles are also positive. I hope you saw earlier, right? Because of the positive repulsion, alpha rays are deflecting in the direction of B, just like I taught here. Is that clear to you all? Right? So there are some questions, right? Okay. And let's go to the answer. So our incorrect statement is the fourth one. So most of you selected that. Let's write why it is incorrect. So can anyone give a suggestion why the fourth one is wrong? It says alpha rays can penetrate through 1 cm thick aluminum sheet because its high kinetic energy acquired due to large mass. So what do you think? Can it pass through 1 cm thick aluminum? Why it is wrong actually? Yeah, anyone? Alpha rays have low penetration ability. Okay, very good. And it is having a large mass. Okay, Yoshita, Sayuri, your answers are correct. And again, Miss Rice telling minimum penetration power, low speed. Yeah. Less penetration. Yes, okay. So the most correct answer is the low penetration ability. Okay. Yeah. Okay. Very good. Yeah. Like that, you have to decide the fourth one is incorrect. So we can write a good explanation for that one. Okay. Okay. Very good. I am very happy about your answers. So fourth one is incorrect. We have to say exactly why. Why fourth one is incorrect. The simplest answer you can give, alpha has a low penetration power. Actually, the lowest of the three types of radiations, lowest penetration power. Just refer to your note, you will understand that. Lowest penetration power. Okay, and you can write something to explain. It is nicely explaining the penetration power. So it's nice to know these things, and you know these things are not asking for the A level, right? But just know what is asking for the A level is this point. Alpha has the minimum penetration power and lowest penetration power, and these are some nice to know points. Okay, nice to know points. So is there any problem here, Lama? And the last statement, okay, last statement is also important. I'll go to that too. Right. So now look at the last statement. Last statement is telling the velocity, momentum, and kinetic energy of cathode rays can be increased by increasing the voltage difference. If you increase the voltage of the cathode ray tube, it is telling that you can increase the kinetic energy and other things for the cathode rays. So that is true. That is true. You have to just remind how cathode rays are given in the cathode ray tube. Then it will be very understandable to you. So this is our cathode ray tube, and we are using a high voltage supply. This is your cathode, to make these electrons go through the non-conductor space. Okay, so electrons are jumping, sort of jumping from cathode to anode. Okay, so if you supply, now already we are supplying high voltage. Okay, so 5 to 15 kilovolts are applied. So if you supply further energy, so if you increase, let's say you are increasing this one 5, 6, 7, 8, 9, 10 like that, you can increase you are giving more push, right? So then you can increase the speed of them, increase the velocity, kinetic energy of them. So it's actually very understandable, because you can write there, in cathode ray tubes, tubes, electrons are passing with the help of high voltage. So if you increase the voltage further, then you can easily pass electrons. Understood, Lama? So you can add further there. Right? That is how you review, some rough review regarding the second MCQ. Okay, second MCQ. Is that clear to you all? The second one? Right? Shall we go to the third one? So first and second questions, most of you have selected the correct answer. That's very good. And now let's check the third one. Third one is a ABCD question. ABCD question. So that means there may be several answers. Several statements are correct. So then you have to select whether it is 1, 2, 3, or 4 or 5 using this table given. If A, B are correct, then you are selecting 1 like that. So let's check your answers. I saw something interesting there, which we need to discuss here. Okay, so third one. Here's your answers. Third one. It is asking the incorrect statements. Incorrect statements. Okay, incorrect statements. So incorrect statements are the A and B. So therefore you have to select the answer 1. Okay, those are the incorrect statements. And see about the answers, Lama. You have selected answer 5 as well, right? So those who selected answer 5 means other combination. So can you tell me, why did you selected answer 5? Those who selected answer 5, just please tell me, why did you selected answer 5? Okay, So here it's not actually bad. So, right, some of you have selected answer 2. That means BC incorrect. So if you write a proper review, I think it will get okay, right? Yeah, we'll see. Okay, so those who got answer 5, please tell me why did you go to that answer. Okay, look at the first one. They're asking the incorrect one. Cathode rays are emitted from cathode and canal rays are emitted from anode. So canal rays, or in other words, you can say anode rays. So why it is wrong, Lamai? Can you type it and send why the first or the A statement is incorrect? Why the first A statement is wrong? Hmm? Yeah, canal rays are not originated from the anode. Anode rays aren't. Yeah. Okay. Okay, very good. Your answers are very descriptive also. Yeah, most of you are telling anode rays are not originated from anode. They just come from the direction of the anode. That's a very good answer. Okay, very happy. Very good. So the first one is wrong. Okay, because of the reason now you just told. Okay, we'll write a good review. So A is wrong. So you can say cathode rays are originating from cathode. Cathode rays, so you can say electrons originate from cathode. We discussed this one in last week discussion also. You can watch that too. I'm just going to write a brief review. So, but anode rays, or you can say canal rays or positive rays. Okay, so those are not originating from anode. Originating from anode. Okay, so they just come from the direction of the anode. Okay, those come from the direction of anode. From the direction of the anode. Or you can just explain why these anode rays, how these anode rays are originated. So these are originated not from the anode, okay? Originated by ionization of gas molecules, or atoms. Okay, so that's how they originated. So within the medium, gaseous atoms are losing electrons, then the positive charges will be formed, and those positive charges are the one positive charged particles are the one who coming towards the cathode. Okay, so that's how the cathode rays are anode rays are originating, sorry. Okay, then when they come to the cathode, through the holes of the cathode, they pass through. Okay, just remind what we discussed last week. I discussed 2 MCQs regarding positive rays. So I remember there was the same theory given in a question. Okay, so you are very good. So that's why the A statement is wrong. Right, now tell me, Lamai, why the statement B is wrong? Why the statement B is wrong? When hydrogen gas present within the discharge tube, EOM ratio for the positive rays is greater than the EOM ratio for the cathode rays. That's what it is telling. Tell me why it is wrong. Why it is wrong. So this is your second statement. When hydrogen gas present within the discharge tube, it is telling that the positive rays are having higher EOM ratio than cathode rays. Why it is wrong? Yeah, EOM ratio of is cathode rays is independent. Okay, because EOM ratio of electrons is 1840 times, while for hydrogen has a 1. Okay. Yoshita, very good. So you are coming to the point. Okay, good. We can say like this, Lama. Okay, we can say like this. E over M ratio for cathode rays is very large. Okay, why? Because mass of cathode rays is very small. So therefore E over M ratio will be a large value. That's simple idea. You can put it into words and write. Okay, you can say the mass of cathode rays, mass of electrons is very small. Therefore, E over M ratio will be high. Okay, but if you take hydrogen gas, so it is having H plus as the positive ray. Okay, so if you take H plus is heavy than electron. That means if the mass is high, then E over M ratio will be low because mass is at the denominator. That simple explanation is enough. If you just refer to the your theory note that I did in the class, you can find exact some value explanation also with values. Okay, so we used in the theory class cathode rays, the hydrogen, the positive rays given by hydrogen gas and positive rays given by nitrogen gas also. Okay, just refer to that discussion, you will understand more. But just know here, it all depends on the mass of the particle. You know, cathode rays are electrons, they are very light particle, so they should have a higher charge to mass ratio. But hydrogen, H plus is the particle, it is somewhat heavier, that's why they have a lower charge to mass ratio. Okay, so if you want to write more, you can write like this. The electron has a charge of -1. If you just say the magnitude, you can say 1, and its mass is 1840 times of the proton. You can write like this, then the value will be 1840. But if you did for hydrogen, it will be 1 over 1. That means the value is 1. So that's why your friend Yoshida said that the value for the EOM ratio value for the cathode ray will be 1840 times bigger than the value for the hydrogen. Okay, so this was explained in your theory note also. Right? So very good. Very good. I'm happy. Okay, good. And then if you go to the C and D, those statements are correct. Let's see why those are correct. Okay, why those are correct. And angle of deflection of positive rays in an electrical field depend on the nature, type of the gas inside the discharge tube. Yes. Okay. So, you know, positive rays can deflect. You know, if it is hydrogen or if it is, let's say, nitrogen plus, it deflects when you put a electrical field or magnetic field. Okay, let's say it is positive and negative, right? So they are deflecting towards the negative field, but the angle of deflection will be strictly affected by the mass of the particle, isn't it? So, for example, hydrogen will quickly deflect, while your nitrogen positive particle will deflect with a lesser angle because it is heavy. Because it is relatively heavy. Okay. So therefore, it is affecting the type of, it is affected by the type of the gas. So that's very true. So you all understood that one. And what about the statement D? Cathode rays and anode rays deflects in the magnetic field to the opposite directions. It is true. You know, any charged particle, we wrote it several times. You can write it today also. Any charged particle deflects in electrical and magnetic field. Okay, and in magnetic field, charge, if the particles are oppositely charged, they will deflect in the opposite direction. Okay, so you can say uh, what it is given here, anode rays. You can say anode rays are positively charged, and cathode rays are negatively charged. So they will deflect in the opposite directions. Okay, so last week again we did a small discussion regarding that too. You can refer to that also, right? You can get exactly where they are deflecting using the Fleming's left hand rule. Okay, you can see the force is applied always perpendicular to the magnetic field. Okay, so it depends on the charge. If it is a positive charge, it is applied to a certain direction. If it is a negative charge, it will be applied to the opposite direction. Okay, so like that you can explain. the D statement also. It's a good question, and most of you got the correct answer, and that's very good. Okay, so you have to select the incorrect ones. Okay, so the incorrect ones are A and B. Okay, incorrect. Okay, now we have the past paper MCQ from the theory point that we discussed several times in our class. It is this carbon monoxide isotope question, right? So let's see how many of you got the correct answer for the first one. I hope most of you got the proper answer. Yeah, of course. Out of the 26 who answered, yeah, 19 got the correct option. Okay, that's very good. Okay, so it's asking which properties show a significant difference. It is carbon percentage and oxygen percentage. Okay, and the theory point we discussed from our last classes is this one. Since their masses are same, they will have similar densities, okay, similar molar volumes and everything, okay, but they have different number of different mass percentages for the carbon and oxygen. Okay, so we'll explain this one here. Yeah, this is your fourth question. See, a certain sample of carbon monoxide, has carbon 614 and oxygen 818. Okay, sorry, or 16. Sorry. And then you have another carbon monoxide sample which contain carbon 612 and oxygen 818. Okay, and the properties that show a significant difference between the two samples. The properties are given as chemical reactivity, carbon and oxygen percentages, and molar mass and the molar volume. Those are the properties given. So let's explain how they are changing. Okay, so they are having, it's the same compound. So isotopes, they have the similar or the same electronic configuration. Because of the same electronic configuration, you can say their chemical reactivity same. So both carbon monoxide molecules will react in the same way. Reactivity is same. Okay, Lama? For this question, you can say carbon monoxide are reacting in the same manner. Because why? Because in chemical reactions, electrons are exchanged. You can write that too. Same electronic configuration. Okay. So during chemical reactions, electrons are exchanged. So therefore, their chemical reactivity will be same. So therefore, A is not the answer. So the chemical reactivity doesn't have a significant difference. Okay, so therefore A is wrong. But if you go to B and C, which is telling about the carbon and oxygen percentage, they will be significantly different. Okay, so you can find the relative molecular mass. Last week also we did the same thing. It is 30. For this also, you can see it is 30. Understood? So if you want the carbon percentage, how do you get it? Here is 14 over 30 into 100%. But here the carbon percentage is what? 12 over 30 into 100%. So now you can see, you no need to find it. Just you can see it is significantly different. Okay, you can do the same thing for the oxygen percentage also. Explaining only one will be enough. Okay. And if you go to the last one, molar mass and molar volume, you can say molar mass and molar volume. This is not that significantly different because relative molecular masses are the same. Therefore, capital N, molar mass is same. same molar mass. Molar volume will be explained more in gases lesson. Okay, so without the gases theories, we can't write a proper review for this one. So molar volume, just put a question mark and keep it there and write unit 4. In unit 4, we will describe regarding gases in much more details, with much more details. So there you can properly explain about the molar volume. Just don't write anything regarding that. Just write only this, that you are going to discuss that in unit 4. Okay, so that's how you go to the answer. So answer is going to be, the correct statements will be significantly different will be answer to B and C. Right? So is there any problem with this one, Lama? I hope it is okay because we discussed the same thing last week. Okay. Right. Now let's go to the fifth one, fifth MCQ. It's asking about alpha, beta, gamma radiation. Alpha, beta, gamma radiation. It's asking the correct statements. Beta rays are attracted towards the North Pole, and the B statement is telling it is attracted toward the South Pole, right? If you just simply remind what we discussed, you can say the both the statements are false, right? And then look at the C, it's still telling alpha rays are repelled away from the positive electrical field, and beta rays are not attracted, gamma rays are not attracted toward the negative electrical field. Those statements are correct. So let's see how many of you got the correct answer for the fifth one. Fifth MCQ. Yeah, 14 of you got the correct answer. Yeah, some of you have selected other combination also. Yeah, we'll see anyway. Okay, we'll see. We'll write a good explanation for that too. I hope you remember the question. Next the question once again. So here, let's say here you are having alpha, beta, and gamma radiations are coming. So alpha is positively charged and beta is negatively charged and gamma has no charge. Just take that one. Huh? So if you put a electrical field, let's say this is positive and this is negative. So what's going to happen? What's going to happen? The negatively charged particles will go towards the positively charged. So here your beta particle will deflect like this, beta. And your gamma particle will pass through without any deflection because it is having no charge. No? And alpha will show a small deflection angle because it is heavy. Okay, without that reason also. Right? So according to this, see, alpha rays repelled away from the positive electrical field. It's true, right? Because alpha is positively charged now. This is positively charged now. Therefore, you can write it is repelled from positive plate and attracted towards negative plate. You can write like that. Okay. So therefore, you can say statement C is correct. So beta is not attracted. That is true. It is not attracting towards any of the fields. You can say D is also correct because sorry, not beta, gamma. You can say gamma is neutral. That is the reason gamma is neutral. Okay, so like that you can decide B and D, C and D are correct. So what about our A and B? It's about magnetic field. Let's say your beta particle is coming here. So beta particles, those are having a negative charge, right? So let's say here you are having a north pole and here a south pole. So when beta particles are coming, you can apply Fleming's left hand rule and see your magnetic field is towards the board. Okay. And if the negative charges are going in this way, you can say current is going in the other way from right to left. So if you put your fingers, again thumb representing the force, index finger representing the magnetic field, and the middle finger representing the direction of the current. Okay, so direction of the current should be there to the to this side. Okay, and magnetic field should be there to the inside the board. Okay, Laman. So the force is applied perpendicularly downward. Okay, perpendicular downward. So therefore, your beta particle will go perpendicularly downward. That means if the beta ray came along the board, it will go along downward along the board. Okay, it will not come. It will not come towards the north pole, or it will not go towards the south pole. Sorry, towards the thing is wrong. Okay, that's why A and B are wrong. So you can write A and B are wrong because charge particles, you can write a common thing. Charge particles deflect perpendicular to the magnetic field. This is a past paper MCQ. Yeah, they deflect perpendicular to the magnetic. Right. So I hope that is clear to you all. Okay, so those are the questions that are coming from atomic structure. So there are 3 more MCQs we will discuss about. We are going to discuss them now. Those are coming from chemical calculations. Okay. Yeah. Okay, Subway is also telling the answer for this one. The same explanation. Very good. Right. So is there any problem with the first 5 MCQs? Is that all clear? We're going to see the chemical calculation questions now. So let's look at the answers first. Now these chemical calculation questions are somewhat, not somewhat actually, they are just similar questions, the same level questions to those you did in the theory class. Okay, in each of your theory classes, you did around 5 to 6 questions with me. Okay, so these 3 questions are at the same level. Okay, so it will be a great thing to do these 3 now as a revision, to revise those things. Right? And do you remember, Lama, we did 4 questions last week, and those are somewhat advanced actually. Okay, so let's consider those last week questions as level 2. So now after completing this discussion and revising the theories you learned in our theory class, just go and check again the last week paper class for MCQs. Those are really good MCQs and some of them are really tough. Okay, so studying them will be a good thing. Okay, so now let's see the 6th question. It is telling ammonia reacts with hydrochloric acid according to the following equation, and to form ammonium chloride. So ammonia reacts with HCl to form ammonium chloride. So is it balanced, Laman? It's already balanced, right? And the mass of ammonium chloride produced from, okay, mass of ammonium chloride produced from, is asking the mass of NH4Cl, that is the question, from 1.8066 into 10 to the power 23 molecules of NH3. So molecules of NH3. That's what they're asking. Okay. So let's see how many of you got the correct response for the 6th MCQ. Yeah, okay, very good. So most of you got the correct answer. And some of you got the answer 1. 5 of you. So that's because of a simplification error. So correct answer is 16.05, and the first option is first answer is 160.5. That because of a simplification error. So that means you have to be careful with the simplifications, yeah. Okay. So now let's discuss about that one. And here you have 1:1:1 ratio. Okay. So we are solving this one using the stoichiometry bridge. You convert this number of molecules into moles of ammonia. Then you use the ratio and come to the desired one. That is the moles of ammonium chloride, then you convert that back into mass of ammonium chloride. So that's how you simplify the question. Understood? To convert the molecules into moles, you have this, you have to divide by Avogadro constant, this formula, and here the ratio is 1:1. That means you don't have to multiply or do anything. It is same number of moles will be here. And to convert the moles into mass, you have uh, moles equal mass or molar mass formula. From that, you have to derive in mass equal moles into molar mass relationship. Okay, so you'll be needing the molar mass of ammonium chloride, right? So capital M of NH4Cl will be, it is like nitrogen is 14, hydrogen 4 is 4, chlorine 35.5. So it's going to be 5, 8, 5, 13, yeah, 1, and 63.5, sorry, 63.5, 53.5, okay, my mistake. Okay, that's correct, no? 8, 5, 13, 1, yeah, 53.5. Right. So now let's find out the moles of ammonium chloride. Okay. 1.8066 into 10 to the power 23. You are going to divide by 6.022 into 10 to the power 23 per mole. Okay. So now you can see it's like if you multiply this number by 3, it is going to be 18.066. 18.066. Okay. So that means if you just simplify it, cut it to pencil, it is going to be 0.3. Okay, so these numbers are also going to get cancelled. So that means you are having 0.3 moles of ammonia. That means since the stoichiometry ratio is 1:1, you will get 0.3 moles of ammonium chloride also. Right? Now you can convert that into mass. Mass equal 0.3 moles into 53.5 grams per mole. Okay, so let's multiply it and see. 3 times 5, 15, 1, 9, 0, 1, 16. Then you have to be careful. There are 2 decimal points because we are multiplying by the 0.3. So the answer is 16.05 grams. It's not that difficult, easy question. Just remind about the stoichiometry bridge. So these ratios are only allowing to the number of moles. Okay, so therefore any given unit, you must convert it into moles. Okay, and then get the ratio and go to the required one and then convert to the desired answer. Okay, it's asking the mass, so we did the simplification like that. So I hope that is all clear to you. It's not that difficult. That's why I said this is a similar question that we did to in our class. So in this week also we are going to do some advanced, somewhat good questions in this week. So you'll see. Okay, right. Now let's go to the question number 7. Seventh question is asking about sodium nitrate decomposition. So let's see how many of you got the correct answer for this one. Just remember the answers given here. See, you can learn something here. So most of you are got the wrong answer. Okay, so that is because of a simplification problem. So in this question, okay, those 11 people who got the answer for did the simplifications correct. Okay, හරි ඒගොල්ලෝ හරියට කරලා තියෙනවා. හරි, but they mix up with the volume. So question is asking the volume in decimeter cube, but in your answer you will be getting the volume in meter cube. That's the problem. You have to convert that meter cube again into decimeter cube. Okay, so those 11 students who got the answer for did not convert the meter cube into decimeter cube. That's why they got wrong. Okay, so they did the question properly. So now understand lamai what we are seeing by these results. Okay, in A-level exam also similar thing. So you have to read the question carefully and look at the answers also carefully. Okay, then you can get these things correctly. Okay, now don't worry anything. Yes, it is good that you got this one wrong. That means you have to practice more. That's it. Okay, You all did the question properly. That's why you got this answer. Huh? But didn't convert the units. Okay. Now let's see the question. Question number 7. Okay. So it is sodium nitrate NaNO3 going to give you NaNO2 and NO2. So if you use inspection method, you must balance this one. It will be 2. Okay. And it is given the mass of sodium nitrate as 34 grams. 34 grams. That means you need to convert it into moles. Moles of NaNO3. And then use the ratio and go to the oxygen. Moles of oxygen. And then you have to go and find the volume of oxygen. Volume of oxygen. To find that, you need not only moles. Okay, you are using PV equal nRT. So from PV equal nRT formula, if you subject the volume, it will be what? nRT over P. So these values are also given. Temperature is given, it is 27 Celsius. And pressure is given, it is what? What is the pressure value? 1.5 into 10 to the power 5 Pascal, like that. The values are given. Okay. So the number of moles you find here have to apply have to apply here and do the simplification. Okay, so now let's see how to do the question. First of all, we have to find the molar mass of NaNO3. This is how you're going to write in essay question. Okay, I explain this also. 23 plus 14 plus 16 into 3. So 16 into 3, 48. Okay, and 14 plus 23. So it's going to be 12, 15, 1, and yeah, 4, 6, and 8, 85, 85, 85. So 85 grams per mole, right? Then you are going to find the moles of NaNO3. You are going to divide this 34 grams but by 85 grams per mole. 85 grams per mole. It's actually divisible. It's actually divisible because 8 times 3, 8 times 4 is 32. No? So 8.5 into 4 will be 34. Okay, it's divisible, right? But you are dividing from 85. That means 0.4. 0.4 moles will be there. Okay, 0.4. So if you are having 0.4 moles of this one, how many moles of oxygen will be there? Because it is 2:2:1 ratio. Okay, you have to divide this one by 2. Remember the method we learned? We are dividing by its own stoichiometry and we are multiplying by the required stoichiometry. Okay, so what should we do to 0.4? We should divide it by 2 and multiply it by 1. Divide by the own stoichiometry and multiply by the required stoichiometry. That's what you should do. Okay, like this. Understood? So then here you will be having 0.2 moles. 0.2 moles. Now we need to apply PV equal nRT and get the volume. Okay, get the volume. Right? So I'm going to apply it here. Moles 0.2. So let's use the SI units and do. So for that Lamai, I have to erase this part. I hope it is all clear to you. Okay. So volume of oxygen equal nRT over P. Moles 0.2. R universal gas constant 8.314 joules per mole per Kelvin. And temperature is, if you convert this 27 Celsius by adding 273, it's going to be 300 Kelvin. And divide it by the pressure 1.5 into 10 to the power 5 Pascal. Okay, right. Now you can simplify this one. So 10 to the powers will be simplified. So 0.2 into 8.314 into 3 division 1.5 into 10 to the power minus 3. So remember, Lama, here you will be getting the answer in meter cube. That's where the people got wrong. Okay, in meter cube. Okay, so you can simplify this. It's going to be 2 and yeah, 0.4 times 8.314 into 10 to the power minus 3 meter cube. So now don't simplify this one. Just look at the answers. Just look at the answer. So answer should be something lesser than 8, no? With into 10 to the power minus 3. So there is only one, no? 3.322 something. So that must be the answer. No need to simplify. 3.3256 should be the answer with 10 to the power minus 3 meter cube. And the answers are given in decimeter cube. So how do we convert that? How do we convert that? Okay. You have to convert this one by by multiplying 10 to the power 3. Okay. So that means it is going to be 3.3256 decimeter cube. That is your volume. Okay. So just remember, how did I told you to convert decimeter cube into meter cube? You just multiply by 1000. If you want to convert decimeter cube into meter cube, you divide by 1000, or you can just say multiply by 10 to the power minus 3. Okay, so that's how you convert them back and forth. Just remember them. I have proved you this one in the class, how to get into this, right? Just remember here. Okay, is that clear to you all, Laman? Seventh one. That's not that difficult, huh? Let's practice. We'll be doing more somewhat advanced questions in this week, right? So I'm telling this lesson is a very good one. So you all have to practice this well, Lamai, because I'm doing this teaching focusing on your results. Okay, so I have been doing this for like few years now. This method, doing 2 lessons parallelly, doing chemical calculations from the beginning, is a very effective thing for you when we are focusing on the exam. Right, shall we go to the last one? Last one. Let's see how many of you got the correct answer for the last one. Question number 8. Okay, 19 of you got the correct answer. Okay, so seems like you are doing very good. Huh? Yeah, this is the last question. It's asking about aniline. Aniline C6H7N reacts with HCl in 1:1 ratio. That's how they react. Later, in a later day, when you are doing organic chemistry, you will learn about aniline. But for now, just the question is telling that already they are reacting in 1:1 ratio. Okay, and it is telling to react with 3.72 grams of aniline. It's asking how much volume is required if the volume of HCl they're asking. So the concentration is given, HCl concentration is 0.2. Okay, yeah, let's do the question and see. So here, first of all, we have to start from here, 3.72 grams. You have to convert that into moles of aniline, then go to moles of aniline, and then you can go to the moles of HCl, and then you have to come back to the volume of HCl. That's how it is going. This is also a stoichiometric bridge. Okay, so let's find molar mass of aniline. Molar mass of aniline, just add 6 times 12. 12 is the relative atomic mass of carbon, and 1 into 7, there are 7 hydrogen atoms and 1 nitrogen atom. So if you add them up, 6 times 12 is 72. 72 plus 7 plus 14. 6, 13. Yeah, 13, 1. And it is 93. 93 grams per mole. Okay, so let's find out moles here. 3.72 grams division, 93 grams per mole. Okay, so it's again divisible, because if you just remember 9 times 4, it is 36, no? Okay, just multiply 9.3 and see by 4. So 3 times 4 is 12. So you are going to add 1.2. That means 37.2. It's divisible, right? Just think like that and do. Okay, so it's going to be 0.4 moles. 0.4 moles. Okay. So since they are reacting in 1:1 ratio, 0.4, 0.4. You need 0.4 moles of HCl also, right? So now you know the HCl moles, and you know the concentration of moles per decimeter cube, concentration of HCl also. So now here the formula should be N equals CV formula. From that formula we can take volume is equal to what? N over C. N over C. So volume of HCl is equal to moles. That means 0.4 moles division, concentration 0.2 moles per decimeter cube. Okay, 0.2 moles per decimeter cube. And here, did I make a simplification error? Yes, no? It should be 0.04. Isn't it? 0.04. 0.04. 0.04. Okay. Right. Now, the answer is going to be 0.2 decimeter cube. So, be careful with the simplification, Lamne. These things may get difficult for you. 0.04 division 0.2. So how do we simplify? Just multiply them by 10. That means 0.4 division 2 means 0.2. Like that, simplify. Okay, slowly. So 0.2 decimeter cube, you must convert it into centimeter cube, because the answers are given in centimeter cube. So how do we convert decimeter cube into centimeter cube? You multiply by 1000. Okay, so you will get 200 centimeter cube. This is the answer. Okay, so it's there as the fourth answer. Most of you got that one correctly. Yes, you have told me the mistake. Okay, thank you. So I didn't saw that the messages. Anyway, I just remember. Okay, good. So these questions you did really good. Okay, right. ඉතින් හොඳටම දිගට කරන් යන්න. මාරි doubts තියෙනව තව අහන්න. මම දැන් අද පොඩි ඉක්මනින් මේක කරගෙන ගියා. So I will be giving you a recording of this class also, right? And write a review using that too. Okay, sure. Okay, then students, good night and study well, and bring the review to our next classes.